Okay, this is example 5. So let's go ahead and try to find the general solution of this, again, non-homogeneous equation. And notice that this differential equation looks very similar to example, I believe it was 3 that I did. The only difference in this equation is this 2 right here. This was e to the 3x if you look at example 3. So again, we want to find our y. So we start with step 1, right, which is solving the characteristic equation, right, to the homogeneous, to find the general solution to the homogeneous equation. But notice we already did this in example 3, right? We found, this was r equals plus or minus 2, and then our general solution was c1e to the 2x plus c2e to the negative 2x, right? So we already did the work. Well, I just went ahead and I wrote it again, but we did this already in example 3, again, because the characteristic equation is exactly the same. But we want to find a particular solution. So here, if you try to construct, so the second step, right, is constructing. So construct y sub p. So we want to choose our y sub p. So choose, and from our last, again, example 3, right, this is an exponential function, right, with multiplied by a coefficient. So we can say, y sub p is a times e to the 2x. Again, very similar to the last example, or example 3 again. And there's a reason why I'm doing this, so there will be a point to this. So we have, let's find y prime, and that's just 2a e to the 2x, and then we have y double prime, and that's going to give us 4a e to the 2x. So if we substitute our values back into our original equation, right, this guy right here, we get the following. So y double prime, so that's 4a e to the 2x minus 4 times y, which is this guy right here. So that's just 4a e to the 2x equals, right, our f of x. So again, I just substituted my yp's back into the equation. Okay, so what happens here when we simplify this expression? Well, we have 4a e to the 2x minus 4a to the 2x. So all this is gone, so we get 0 equals 2e to the 2x. We know e to the 2x is not 0, so we can definitely divide both sides by e to the 2x, which just implies that 0 is equal to 2. Well, this is obviously a false statement. So this is good because this tells us, okay, something is wrong. Maybe the choice for y sub p wasn't the best choice, because again, I'm doing the math and I'm getting this equation, and 0 is obviously not equal to 2. So this is where we try to choose maybe a different p. Okay, so let's try a different p. So let's try choosing, so we still have our exponential function, so we can do a and then maybe multiply by a factor of x. So a times x times e to the 2x. So we're going to try this, and here we're going to use the product rule because we're multiplying two functions, right? So again, I'm just using the product rule when differentiating, and I'm just going to go ahead and write it in. It should be review. You can do it on the side if you'd like, but when you use the product rule, we end up getting a e to the 2x plus 2ax e to the 2x, And then if we differentiate again, we get, again, using our, let's see, product rule again, and then, well, this is pretty easy, and then, of course, combining all the terms, we're going to get 4a e to the 2x plus 4a xe to the 2x. Okay, so now let's substitute these guys back into our original equation. And so when we do that, let's see, I already forgot my differential equation. So y double prime minus 4y. So y double prime, okay, is this guy. axe minus 4y minus 4axe to the 2x. And that was going to, I believe it was, yeah, 2e to the 2x. Okay, so now can we combine any like terms? And we sure can, right? These guys are gone, right? They're exactly the same. And then we're left with 4a e to the 2x equals 2e to the 2x. So here, now we can, we want to equate the coefficients. So, I mean, here we don't get a false statement, right? This is e to the 2x, this is e to the 2x. Well, if these guys are equal, that means these guys are equal, right? So that implies 4a equals 2, which is just simply a half. So a is a half. And so now let's, what's our y sub p? Well, my y sub p, and again, our new choice, we tried, it was a, well, let's go ahead and write it in. It was ax e to the 2x. But we just found our a, so this is 1/2 xe to the 2x. And our final solution, right, if you want to maybe say step 3, right, y equals y complementary plus y particular. So then we get, right, from step 1, I believe it was c1e to the 2x plus c2e to the negative 2x. And then, right, so that guy's the same, plus, right, our y sub p, which is 1/2 xe to the 2x. So again, your y sub p, right? So this is your final, right? This is the most general solution to the non-homogeneous equation. And I want to explain something really quick just before we're done with the problem, but I want you to see why. Okay, so here's our, let's go a little bit higher. Okay, so here is our original, right? We tried at the beginning, we tried choosing our y sub p to be this. Okay, and of course, doing the math, right, we see that we get a false statement, so that can't work. But if you didn't check this, I mean, which you should, I mean, because you're usually going to, I mean, you are going to substitute it back into the equation. But if this was your y sub p, right, some constant times e to the 2x, well, if that was the case, let me move this back up, right? If, right, this is obviously the correct, answer, but if I put, you know, a times e to the 2x here, right, and let me go ahead and write this part. So c1 e to the 2x plus c2 e to the negative 2x. If I said, so if I wrote this and said, okay, this is the most general solution to the non-homogeneous equation, I want you to see that there's something, hopefully this looks a little strange, or maybe not strange, but maybe redundant. This guy, okay, so this part, okay, is a constant times this exponential function, right, e to the 2x, okay, plus a constant times an exponential function raised to the negative 2x. Okay, and then we're adding this, usually we're adding something new here, but this is not new, right? This guy, right? This is already contained, right, in this sky, right? That's, I mean, that's just a constant. That's just a constant. So we're not adding anything new to the table here. So that's why we can't use this one. It doesn't add anything new, but if we multiply by a factor of x, then, I mean, then this sky does not live, right, in this sky. So that's the reason why. So again, we want to add something new, not something that's already there.